So, hi everyone, I'm Mari, and today I'm going to be talking to you a bit about system serology. I'm aware this probably means nothing to you right now. It's unfortunate that the field I study doesn't have a title that is easily communicated, but hopefully by the end of the presentation we might understand a bit more about what this all means and why it's important. So, a bit about me. I'm a Libra, if that counts for anything. I think it does like that, which is a community bit. And yeah, but really why I use this is because when I was about 15, 16 and choosing A-levels, I was really torn. I was torn between going into the field of STEM or either going into the field of humanities and literature. Also, very importantly, maybe around about the same time, I was deciding, or thought I had to decide, whether or not I fancied Taylor Lautner or Taylor Swift. So, yeah, the big decisions of life. Luckily, I realised, maybe comparatively late on in life, that you could do both. So I did my undergrad at Bristol studying cellular and molecular medicine. Still maybe tragically believing I could only fancy Taylor Lautner. Before coming to Oxford to start my DPhil in infection, immunology and translational medicine is the title of the course. And it's a 1+3 year course, so my first year I've just been rotating around labs. I was in biochemistry, and now I'm at the Oxford Vaccine Group, which is where I do my PhD. And yeah, like the other speakers said, why I wanted to do this presentation was because, you know, maybe at like spoken word events I go to, there was like nicely a good LGBT representation there, but you know, when I looked around labs, there really wasn't. So, back to the main point of what I do and what I study, and that is typhoid fever. And typhoid fever is caused by Salmonella bacteria, and globally it causes about 20 million infections, 200,000 deaths, and there's a lot of antibiotic resistance to the bacteria. So we need a good vaccine to combat this. The problem is the vaccines at the moment are only really effective in adults. So we're clinically trialing some pediatric vaccines. And that is where I apply systems serology to, which again I will eventually explain. And yeah, so what systems serology does is we look at functional antibody responses. In my case, I'm applying it to typhoid vaccinations. So we aim to integrate lots of different types of data around serology, which is antibodies, basically. So the functional outputs, as well as looking at the more basic stuff like how many antibodies there are after vaccination. But I'm aware we come from different backgrounds here, so I thought I'd start by just briefly explaining what vaccines do. So vaccines take an inactivated or even just like a little part of the pathogen that you're trying to create an immune response against. So in this case, we have an inactivated form, very representative picture of Salmonella bacteria. And when we inject this into our bodies, it stimulates a memory response, these memory B cells. And these become important when you get subsequent infections. As you can see, we now have the actual Salmonella bacteria. But in this case, we now have memory B cells that we've acquired from the vaccination. And these memory cells are able to stimulate effector B cells. And these are the ones that are really going to mount a response super quickly, take down the pathogen, no infection. That's why we have vaccines. This same process happens maybe without a vaccine, but it's going to take a lot longer and you're going to get sick and maybe die. So, what are these effector B cells doing? Well, phase 2, they like to secrete antibodies, and I think of antibodies as being kind of the weapon in this scenario. So antibodies are molecules that can stick and surround the pathogen and prevent infection, prevent them from invading cells and you getting sick. However, that's not the full story when it comes to antibodies. So when we looked at recent clinical trial data of typhoid vaccinations, we found that just looking at how much antibody there was, how much it was sticking to the pathogen, didn't necessarily correlate with whether or not you were protected from infection. What was important was the antibody subclass, and that's determined by the Fc region of the antibody here. And you've got a bunch of different subclasses, and this region brings us onto phase 3, sorry, which is reinforcement. So the Fc region is able to bind to reciprocal Fc receptors on a bunch of different immune cells. And so it can bring in these immune cells that can then help take down the pathogen, engulf it, and prevent infection from spreading. So the responses I'm looking at in particular in my research are antibody-dependent neutrophil and monocytes, phagocytosis, and also you get these really cool cells called natural killer cells that come in and secrete molecules that will also help kill the pathogen. Yes, so that's kind of where I'm at in my PhD. I'm developing assays that will allow us to measure and quantify this functional antibody response that we think is really important in vaccination. And that's kind of been done. And going forward, we're applying this to challenge studies. So that's where we get volunteers in Oxford, normally poor students, looking to get a bit of cash, and they, get the vaccine, drink a bit of Salmonella typhi, and we see if they get ill or don't. It's a great trial. Do sign up if you want to help the scientific community and public health. But what's really good about these challenge trials is it means we can get data. It means when we apply these assays and we can see that, okay, there's this functional antibody response going on, that we can immediately see, was it protective or was it not? So we have this challenge trial data, and then the next long-term phase of my PhD is to then apply that to, if we can figure out how the vaccine response is protective in these small studies, we can try find these same signatures or correlates of protection in large-scale field studies. So in the case of typhoid, we've currently got some clinical trials going on in Nepal, and if we can apply these assays to those clinical trials, see the same protective response going on, we know that's going to be a good vaccine. Great, roll it out and help cure people that need it as soon as we can. So yes, that's me. Thanks for listening.